Welcome to part 2 of solving systems of equations using elimination and all methods. Notice the system below. Maybe even pause the screen and decide, okay, can I put that 3 into a 10, or can I get 9 into 7, or do they have any common factors? And the answer here is no. So in this case, we're going to have to multiply both equations by a number and sometimes even a negative. Let's take a look at the first example. Maybe pause the screen and decide what you might multiply by. There are several different ways to do this problem. I'm going to use the x's here, and I'm going to flip-flop the numbers 5 and 2. Notice I did not take the negative 2 with me. I'm going to decide if I want to put a negative in the top based on if I need to change the signs. Because it's a negative 2 and a positive 5, I don't actually need to change the signs, so I'm not going to multiply by a negative anything. I'm going to distribute that 5 to every number in the top, the 2 to every number in the bottom. I'm going to get negative 10x plus 20y is equal to 30, and 10x minus 12y is equal to negative 22. These eliminate. Now, if you got into a situation where they didn't eliminate, it probably is because you brought a negative. It's an easy fix. You can just multiply that whole equation by a negative. We get 8y is equal to 8. Divide both sides by 8. Y is equal to 1. We're halfway done. We're going to place that y. I like to put it into the top equation. We get negative 2x plus 4 times 1 is equal to 6. We get negative 2x plus 4 is equal to 6. We'll subtract 4 on each side. Negative 2x is equal to 2, running out of space. X is equal to negative 1. Just be careful. We did find y first, so the tendency is to put whatever you got first, but it's always x, y. So make sure it's negative 1, comma 1. Let's do that example that we looked at in the notice. So we have that 3 and that 10, the 9 and the 7. And I'm just going to box those x terms again, and I'm going to flip-flop the 10 and the 3. And then I'm going to decide if they would eliminate without changing the sign. I've got a positive 3 and a positive 10, so that won't work. I need to multiply the top by negative 10. So we're going to distribute that to the top, all the numbers. They are going to get big here. Oops, that's negative 30x minus 90y is equal to negative 240. And then we've got down here 30x. You should check, oh yeah, those are going to eliminate. Plus 21y is equal to negative 36. They eliminate. We get negative 69y is equal to negative 276. We divide negative 276 both sides by negative 69, and we get y is equal to positive 4. We're going to take that 4 and plug it in for y here. So we've got 3x plus 9 times 4 is equal to 24. That's 3x plus 36 is equal to 24. Subtract 36 on both sides, and we get 3x is equal to negative 12. Divide both sides by 3. X is equal to negative 4. That's the ordered pair, negative 4, 4. We'll do one more example together. So that is solve the system. Maybe pause the screen here and take a look at what you might box. Maybe you just always want to box the x's, that's okay, or you want to have the smallest numbers. I'm going to do the x terms again, switching the 3 and the 4. Decide if I need to change the negative or not. So I've got a negative 4 and a positive 3. They're already opposite signs, so I don't need to change them again. So I'm going to distribute that 3 and that 4. And that's going to go like that. Negative 12x plus 15y is equal to negative 33. 12x minus 16y is equal to 36. The x's eliminate. We get negative 1y is equal to 3. Divide both sides by negative 1. Y is equal to negative 3. We're going to take that y and place it back into that original equation. We get negative 4x plus 5 times negative 3 is equal to negative 11. Negative 4x minus 15 is equal to negative 11. We'll add 15 to both sides. we get negative 4x is equal to positive 4. Divide both sides by negative 4, x is equal to negative 1. So the answer is negative 1, negative 3. Remember, you can check this always by plugging it into the other equation and seeing if in fact it works out. Got 2 problems on the next slide. Pause it to work these out. Number 1, see if you dropped any negatives. Note my work and your work if we mixed up the x and the y. And number 2. Now at this point we've covered graphing, substitution, and elimination, so you can solve systems using any method, but there is a better idea for each one. So when we graph, we're really only graphing if they're both y equals mx plus b. For substitution, we're using it only when one is y equals or x equals, and elimination when they're both in standard form. So on the next slide here, pause it, take about 10 to 20 minutes to work on all these problems. If you're graphing, please use graph paper to really see the answer carefully. And I will show you the answers as well as what method I used on the next slide. And that concludes the second part of solving systems of equations using elimination and all methods.